For introduction, a vector is a mathematical entity that fulfills the law of vector addition and has magnitude and direction. Rate of change describes the rate at which something changes over time. Thus, it is not the amount of individual changes themselves, but rather the acceleration or deceleration of changes.
In this question, we use the formula of area, which is pi r square, and we differentiate it dA over dr equals to 2 pi r. We need to find dA over dt, so dA over dr times dr over dt, so that we can remove the dr. Now, we know that the dA over dt is 2 pi r times dr over dt. Look at the question. dr over dt and radius are given. So we just need to plug in the values in the equation to get the answer.
For question 2, a 20-meter ladder leans against the wall. The top slides down at rate of 4 ms per minute. How fast is the bottom of the ladder moving when it is 60 meters from the wall? For this question, we can use theorem Pythagoras to create an equation. Here we get x power of 2 plus y power of 2 equals to 20 power of 2. And then we sub in x equal to 16. We get y equals to 12. From the question, we also get dy over dt is equal to 4. Then we need to find dx over dt. From the equation we have here, we need to differentiate it to get dx over dt. When we differentiate x power of 2 dx over dt, we get 2x dx over dt. And then we differentiate y power of 2 dy over dt, we get 2x dy over dt. And then lastly, we integrate 20 power of 2, we get 0. Here we sub in x equals to 16 and y equals to 12. We get 32 dx over dt equals to negative 96. We just divide 96 with 32, we get negative 3 over 2 ms power of negative 1.
In this question, we also use formula of area, which is pi r square, but before that, we need to jot down all the values that given in the question. The radius is 4 meter and the dr over dt is 0.5 milliseconds. We need to differentiate the area dA over dr equals to 2 pi r, and we need to find dA over dt, so dA over dr times dr over dt, so that we can remove the dr. Now, we know the dA over dt is 2 pi r times dr over dt. When we get the dA over dt, we just plug in the values that we jot down just now. 2 pi and r is 4, dr over dt is 0.5 milliseconds. So, we got the answer.
As for rate of change, I'll be presenting question number 4. The question is, an Earth satellite moves in a part that can be described by x squared over 72.5 plus y squared over 71.5 equal to 1, where x and y are in thousands of kilometers. If the differentiation of x to t of 12,900 km per hour for x equal to 3,200 km and y is bigger than 0, find dy over dt. To answer the question, first we have to rewrite the equation back as x squared over 72.5 plus y squared over 71.5 equal to 1. The differentiation of x squared over 72.5 should be multiplied with dx dt, and the differentiation of y squared over 71.5 should be also with dy dt, which will be equal to 0. 2y over 71.5 dy dt equal to negative 2x over 72.5 dx dt, because we took one side and bring it to the other side. which give us dy dt equal to negative 71.52 multiplied with 2x over 72.5 multiplied with 2y dx dt. Now we have to substitute the unknown with the given volume, which is x equal to 32,000 kilometer. We will get the answer for dy dt, which is equal to negative 5195 kilometer per hour.
Hi, my name is Hariram. I'm from Group 3. I'm entry number CN22047. Today we will discuss about rate of changes, question 5. As you see, the question I've asked, the tuning frequency f of electronic tuning is inversely proportional to the square root of the capacitance C in the circuit. If f equals to 200 kilohertz for C 300 power frequency, how fast the f could be changing this frequency if dc over dt equals to 0.3 power factor per second. So you can see C equals to capacitance, PF equals to power factor, which is the unit for hertz. So for capacitance, so we want to find the DC or DT for frequency. First of all, F equals to, the formula is K over square root C, which equals to K equals to F bracket square root C. Then the value of the capacitance is 3.5 PF power factor. The frequency is 920 kilohertz. So next step is you have to times the both of them. So 920 kilohertz times 3.5 power factor equals to 1.721. The next step is F equals to K over C. So 1.721 equals divided by the square root of C. So F is 1.721, C negative power to the 1/2. So we already find the value of F3. So now we have to differentiate it. So df over dt equals to half bracket 1.721 C power to negative 3 over 2. So df dt 1.72 over 2 times bracket 3.5 to the power of negative 3 over 2. So you will get negative 1.31 times 10 to the power of 17 bracket 0.3 pf power factor. And lastly you get answer negative 39.425 hertz per second. So this is the working method and it's the solution for the question number 5. Thank you.
As for vector, I'll be presenting question 1 until 3. Starting from question 1, the question is to sketch a graph of the curve traced out by the endpoints of the following vector value function. Indicate using an arrow the direction in which t increases. Starting from question number 1a, the question is rt equal to 3, negative 1. So using the xy graph, the graph of the curve was sketched and finally labeled, where negative 1 was y and 3 was x, and rt equal to 3, negative 1 is also written down in the graph in the final answer. Next is question 2. Question 1b. rt equal to 3, 7, where it was also sketched just like in question 1. The graph was sketched using the xy graph line, xy graph again, where everything was properly labeled, where 7 is y and 3 is x, and an arrow is drawn where t increases, and rt equal to 3, 7 is also labeled. Next is question 1c. In question 1c, we have 3 points this time, 3, 5, and negative 4. That was given rt equal to 3, 5, negative 4. As it's shown in the drawing, we draw the entire. We sketched the graph again, and traced it, and find and label properly the 5, 3, and negative 4. Question D, where there is also 3 line, 1, negative 4, and negative 3. rt equal to 1, negative 4, negative 3. Where we also sketch it on a xy graph, y-x graph, and everything is correctly labeled again. Number negative 3 is labeled at y. Negative 4 is marked on line Z. Line X is also there, where 1 is on line X on an arrow X, and arrow were put in to indicate where X increases. And also the level for RT equal to 1, comma -4, comma -3 is also written below. And now for vector, question number 2. For question number 2, given that f equal to ti plus 2tj plus cos tk and g equal to 3ti minus tj plus 2k, and we are supposed to find a, b, c, and d. For question 2a, we have to find f plus g multiplied with t. We have to find f plus g, as f is ti plus 2tj plus t plus cos tk. We just rewrite the equation for each f and g is 3ti minus tj plus 2k, which after being added together, you will get 4ti plus tj plus cos t plus 2 in a bracket and then k on the outside. We simplify the ending part. This same equation now is being multiplied by t. By multiplying with t, we will get 4t squared I plus t squared j plus t cos t plus t2 with t cos t plus 2t in a bracket and a k outside, as we simplify the last two equations. As for question 2b, we'll be looking for f multiplied with g in a bracket multiplied with t. First, we start with multiplying f times g, which will give the answer 4 plus cos t in a bracket and I on the outside minus 2 plus negative 3t cos t in a bracket with j on the outside plus k with bracket negative t negative 60 inside it. This will therefore give an answer of 4 plus cos t in a bracket I minus 2 plus negative 3t cos t in a bracket j minus 7tk. Now this equation will be multiplied with t, which will be giving the answer of 4t plus 4 cos t in a bracket I minus 2t squared minus 3t squared cos t in a bracket j minus 7t squared k, which can be simplified into 4t plus 4 cos t in a bracket I minus 2 minus 3 cos t in a bracket t squared j minus 7t squared k. As for question 2c, we are going to find f point g multiplied with t. F point g, first we have to find that, which will be t multiplied with 3t plus 2t multiplied with negative t plus cos t multiplied with 2, which will give us the answer of 3t squared minus 2t squared plus 2 cos t. Now this equation, f point g, is going to be multiplied with t, which will give us the answer of 3t squared minus t squared plus 2 cos t in a bracket and t outside, which will give us the answer of 3t cubed minus t cubed plus 2t cos t. As for the final question for 2d, we will have ft point f times g multiplied with t. To find the solution for this question, first we will start with looking for ft, which is ti plus 2tj plus cos tk with a t outside, and then which will give us the answer of t squared I plus 2t squared j plus t cos tk. Next, we need to look for f times g. F times g is 4t cos t I minus 2t minus 3t cos t, which we have found from the other equation before this. Sorry, just now it's plus cos t bracket in j minus with j with 7tk. This equation then will be multiplied with t, which will give us at the very ending, 4t plus t cos t in a bracket I minus 2t squared minus 3t squared cos t in a bracket j minus 7t squared k. This question then, we are going to go back to the first beginning, which is ft point f times gt. So we'll just have to input the two equations we already did before, which will give us the equation shown below, and the final answer will be 4t cubed plus t cubed cos t minus 4t with a small 4 plus 6t with a small 4 cos t minus 7t cubed cos t. That will be it for question number 2. Next, it will be question number 3. As for question number 3, we are actually asked to find the first differentiation of the vector value function and also the second differentiation of the vector value function. In the question number 3, we only have two questions, A and B. Starting from question 1, RT equal to Ti plus T squared J plus T cubed in a bracket with K outside. This question is more simple and very forward. So the solution is shown here. We just differentiate like normal for the question number 1. RT, I use the product rule to actually find the answer for t plus t3 for t plus t3 cubed with a t outside, where t plus t3 cubed became u, and the t outside I took it as v, which give us the answer of 2t plus 4t cubed. And then the answer for the first differentiation altogether is I plus 2tj plus 2t plus 4t cubed. As for the second differentiation, we just did a straightforward differentiation here using power rule, where we got the answer 3 plus 2j plus 12t squared. At first we get 1, differentiation of I is 1 plus 2j plus 2 plus 12t squared, and then after simplifying it we get 3 plus 2j plus 12t squared. As for question 3b, it's actually a little bit more confusing and complicated to solve. So the question is r theta equal to sine squared theta I plus cos 2 theta j plus theta squared k. So the first differentiation for this, the answer was 2i cos theta I sine theta I minus 2j sin 2 theta j plus 2k theta. However, I got this answer is through using chain rule, where I use sin o I as u and y equal to u squared, and du d theta equal to I cos theta I, and dy du equal to 2u. So I found dy and then d theta using I cos by using the differentiation of u multiplied with the differentiation of y, where the answer is 2i cos theta I sine theta I. This equation can then be simplified by the equation can then further be simplified into I sine 2 theta I and then plus 2k theta minus 2j sine 2 theta j, which can be rearranged into 2j theta, can be added. I sine 2 theta I can be minus with 2j sin 2 theta j, and then be simplified into 2j theta plus I sine 2 theta I minus 2 plus 2k theta. That will be the answer for the first differentiation for question B. And then for second differentiation, the answer will be we'll take 2j theta plus I sine 2 theta I minus 2 plus 2k theta, and that will be simplified into 2j plus 2I square cos 2 theta I plus 2k, which can then be simplified and rearranged into 2j minus 2 cos 2 theta I plus 2k. To get this answer, I use I believe I used the chain rule again, as is shown here. I did use the chain rule again to solve this question too, together with power rule, just like normal. That will be it for me today. Thank you very much.
Number 4a, we differentiate r and we get 2ti plus j. We get dt equals to 2ti plus j divided by square root 2t square in bracket power of 2 plus 1 power of 2. Then we substitute t1 equals to 2i plus j equal j over square root 5. So nt is t prime t over modulus t prime t. We need to differentiate r for the second time and we get 2. Then we substitute into formula nt equals to 2i over square root 4. So nt equals to I and replace the t with 1, so we get the answer. Number 4b, we differentiate r and we got negative 5 sin tj plus 5 cos tj. Then plug in the values in equation tt and simplify to get the answer for tt. Next, we need to replace t in bracket to 1 over 3 pi, so it will be negative sign in bracket 1 over 3 pi I plus cos in bracket 1 over 3 pi I. We need to differentiate r again, so it will be negative 5 cos ti minus 5 sin tj. We simplify the nt and we get the negative cos ti minus sin tj. Then we replace the t with 1 over 3 pi and we got the answer. Question number 5a, we need to do second derivative. First derivative is negative e square sin ti plus e square cos tj. Second derivative, it will be negative e square cos ti minus e square tj. So kt is square root negative e square cos t in bracket power of 2 plus negative e square sin t in bracket power of 2. We calculate and we get the answer. Number 5b, we also need to do second derivative. So first derivative is 2i plus 2tj plus t square k. Second derivative is I plus 2j plus 2tk. So kt equals to square root 2 power of 2 plus 2t power of 2. Then we get the answer. Question 6a also need to do second derivative, but we need to replace the t with the value given, which is t equals to 1 over 2 pi. Then kt is square root negative 3 cos t in bracket power of 2 plus negative 16 sin 2t in bracket power of 2. So it will be square root 9 cos square t plus 256 sin square t 2t. So we replace the t with 1 over 2 pi, then we get the answer. Question 6b also need to do second derivative, but we need to replace the t with the value given, which is t is 1. Then kt is square root 2 square plus 2t in bracket power of 2. It will be 2 plus 2t. So we replace the t with 1, then we get the answer.
Hello, my name is Hariram and I'm from Group 3. I'm out of my metric number is CN220047. Today we will discuss from the topic vector question number 7. Question number 7 as stated, given the vector value function rt equals to 2 sin t I plus cos 2 cos t j plus tk, find the unit tangent vector, principal unit vector and binomial vector and curvature at t. So let's find the solution. This is the solution. First of all, you have to write this equation. Rt equals to 2 sin ti plus 2 sin cos tj plus tk. So k equals to 1t. With that, just write r1t 2 cos I ki minus 2 sin kj plus k. So next step, you have to put r prime t equals to square root in a bracket 2 cos t square and then 2 sin k square plus 1. So we have gotten 4 cos t square, so then plus 4 sin square k plus 1. So in the bracket you will get 4 plus 1 over square root, then you get 5. The next step is tk equals to rt over r bracket t equals to 2 cos ki equals to 2 sin tj plus k over negative 5, positive 5. The next step is r positive k equals to 2 sin ki minus 2 cos kj. After that, r prime bracket k equals to square root bracket negative 2 sin k square plus negative 2 cos t plus square. So the same again, you get 4 sin 2 k plus 4 square k. So end of that you get square root 4, which equals to 2. So nk equals to r prime t over r prime t, which equals to 2 sin ti plus minus 2 cos tj over 2. So you will next get the value I and j equals to 2 over 5 cos x negative sin k in j to negative 2 sin k over 5, then negative cos k. You have to cross multiplication. So bt equals to I bracket negative 2 over 5 sin k times 0 plus cos k times 1. Then for j, 2 of square root 5 cos k times 0, you times with sin k 1 plus k equals to negative 2 over 5 square root 5 cos k minus cos k plus sin k minus 2 over square root 5 sin c. So you will get negative 1 bracket cos k minus j sin k plus k bracket negative 2 square root 5 cos k square, then minus 2 over square root 5 bracket sin k square. So this is the solution for question number 7. Now we are looking for question 8. Question 8 has said it, evaluate the following integrals. So let's look at each question. First question A, you have to integrate TEI plus e power to negative 2tj plus 5 bracket t1 k. So we have to integrate it. So first step, just write the equation. Once that, after that you put a bracket. So the next step, bracket integrate te power to ti plus integrate e negative 2t j, then bracket 5 then you put the bracket integrate bracket t minus 1 then close the bracket k. So after that you have to substitute the t la. So you have two values. So t et minus et I, then plus bracket negative 1 over 2e power to the et j plus 5 bracket t square over 2 minus k to the power of k. So you close bracket, then you get k. After that, t power to the k minus ek equals to I part minus 1 over 2e to the power of 2k, which is j, plus then 5 bracket k square over 2 minus k over the k. This is the solution for the first question, 8a. Now let's for the 8b, which is stated integrate t I n ln ti sine bracket 1 minus t j plus tk. So to integrate this question, same like that. So now you have to just write the equation. Integrate k ln k dt, then sine negative bracket 1 minus k, then this is j, then lastly you have to integrate the k. So you find the one value, it is to eu ln t, so you differentiate it, you will get 1 over t, okay, the value. Next step, dv equals to k, so you integrate it, you get v k square over 2. So now you have to just times with it. So ln 2k times k square over 2, then you integrate k square 2 minus 1 over t dt, which is I. Then for another bracket j, you integrate sine 1 minus k in a bracket, and lastly you just integrate k for the third bracket. So you will get bracket t square ln t over 2 minus k square over 4, which is for I, then minus cos bracket 1 minus k, which is for j, and lastly plus t over 2 bracket square t over 2 square k plus c. So this is the solution for 8b. Next up we're going for question number 9, which is two questions A and B. Let's go at A. To integrate t square I plus e to the power of k j plus 3k. So just write in different three brackets. To integrate k square, then you have to integrate e to the power of k, then you have to integrate 3k. So by that you will get a values. So now you get a value in a bracket t power to 3 power to the 3 over 3 plus e to the power of t j plus 3t. So by this you automatically substitute the 1 and 0 to the t which is in the value. So you get 1 over 3 plus e to the power of 1 j plus 3 to the power of 1 k minus 0 to the power of 3 over 3, so plus c to the power of 0 j plus 3 to the power of 0. So you get 1 over 3 I plus bracket e minus 1 j, then plus 3k plus c. So this is the solution for 9a. Next we go for 9b. The question for 9b is equals to cos ti plus sin t j minus 2t k. So I have to write it value. So you have to select it. So integrate cos ti plus integrate sin t j minus integrate 2t k. So by this you get two things, sin t I minus cos t j minus 2t2 k t square k. So you substitute the pi value and 0 value into the t, so you will get sin pi I minus cos pi j minus pi square k minus another bracket sin 0 I cos 0 j 0 square k. So the value equals to 0 I plus 0 j minus pi square k. So this is the solution for 9b. Next up we go for question number 10. So let's look at question number 10. Question number 10 says that RT is the position vector for particle in space of time t. Find the particle's velocity and acceleration, hence finds the speed and direction of the motion for the given value of t. Now look at the two questions. A says RT equals to 2 cos t I plus 2 sin t j plus tk, t equals to 1 over 4 pi. So next up is RT, about the B question. RT equals to 2 ti plus 3 ln t j plus 3 to the power e to the power of 2t k, and the value of t is 1. So now look at the question A. The solution for question A is, you have to write it 2 cos ti plus 2 sin t j plus tk, t equals to 1 over 4 pi. So substitute r prime, so the value will be different. 2 sin t I plus 2 cos t j plus 1k. After this you will get speed t 1 over 2 r t equals to square root bracket negative 2 sin t square plus minus cos 2 cos t square plus 1 to the power square. So this will equal to 4 sin square t plus 4 cos square plus 1. So end of the day you take out the 4, you will get the bracket sin square plus cos square t, so plus 1. So you get answer, you get the 5 to the right. So the answer is 5 lah. The next up is B question. 2ti plus 3 ln tj plus e to the power of 2tk. The already said k's value is 1. So now we have to just t to the power of 1. So rt 2i plus 3 over t j plus 2e to the power of 2t k. So we have to find the speed lah. So speed equals to rt same square root 2 square plus 3 over t square plus 2e to the power of 2k square. So you get bracket 4 plus 9 over t square plus 4e to the power of 4t. So square root 4 plus 9 over 1 square plus 4e 4 to the power the t equals to 1. So you times it all the value. Once you get all the value plus it and you square it, you'll get the value. So the answer to the value of is 15.21 to the right. So that's the value for question B. Once you plus all the value and you square root, you'll get 15.21. So this is the question for 10. So after this will be presented after this the questions will be presented by my friends.
Question 11. Use the given information to find a position vector RT. Given VT equals to t power of 2i plus e power of 2tj plus tk, and R0 equals to I plus j plus k. First, we need to integrate the question given, that is t power of 2, we integrate, we get t power of 3 over 3. Don't forget to put up the constant I, because it is easy for us to integrate. And then we integrate e power of 2t, we get e power of 2t over 2. And then we integrate t, we get t power of 2 over 2. Don't forget plus c. And then here we sub in 0 to t, we get 0i plus 1 over 2j plus 0a plus c. And then we are given R0 is equal to 1 plus 2j plus k. From the given R0 and V0, we already find we can get C equals to 1 plus 3 over 2j plus k, because here just move 1 over 2j and then we get the answer for C. And then RT is equals to t power of 3 plus 1. Here t power of 3 over 3 plus 1. And then e power of 2t over 2 plus 3 over 2, here j. And then for k, t power of 2 over 2 plus 1. We get the answer for 11A. And then 11B, we have Vt equal to 2 sec ti plus cos tj, and then we just need to integrate it. We get t power of 3 over 2 over 3 over 2. Don't forget to put out the constant outside for us to easier to integrate. And then cos t, integrate it, we get sin t plus c. Don't forget the c. And then we sub in 0 into this equation, we get 0i plus 0j plus c. And then we can easily get c is equal to 1. C is equal to I plus 2j, because here given R0 equals to 1 plus 2j. And then we combine the C with Vt, we get 4t power of 3 over 2 over 3 plus 1. I plus sin t here, j plus 2j, we get the answer. For question number 12, the velocity of a particle moving in space is Vt equals to e power of ti plus e 4tj plus sin pi tk. Find the particle's position in terms of r0 equals to 2I minus j plus 1 over pi k. Again, just integrate the question given. We integrate e power of t, we get e power of t. Integrate t, we get e power of 2 over 2. And we integrate sin pi t, we get cos pi t over pi plus c. And then sub in 0 into this equation, we get I plus 0j plus 1 over pi k plus c. And then again, we have here r0 equals to 2I minus j plus 1 pi k. We can easily have the c is equals to 1 minus j plus 2 over pi k. If you still don't understand how we have c, we just put v0 and r0 next to each other, and then we just easily can get the c. And then lastly, we can find rp is equals to ep plus 1. ep is here, 1I is here, and then just copy it, and then here 2t j minus 1j we get here, and then minus cos pi t over pi here plus 2 over pi k. For question number 13, the acceleration of a particle moving in space is at equals to cos 2ti minus 4j plus e power of 2tk. Find the particle position in terms of t if r0 equals to 1 over 4i plus 2j plus 3k and v0 is equal to 0. Firstly, we need to integrate the question. We integrate cos 2t, we get sin 2t over 2, and then we integrate 4, we get 4t, and then we integrate e 2t, e power of 2t, and then we get e power of 2t over 2 plus c, and then sub in 0, we get 1 over 2k plus c, and then here we have v equals to 0. We can find c is equal negative 1 over 2k. Just combine the two equations, c and at, we get sin 2t over 2i plus 4tj plus e power of 2t over 2 minus 1 over 2k. Thus here k and k, we can combine it. And then integrate again the equation that we have. Integrate sin 2t, we get negative cos 2t over t. Don't forget to put out the constant here, 1 over 2. And then here, integrate t, we have t power of 2 over 2. And then integrate e, 2t over 2, we get e power of 2t over 4, and then integrate 1 over 2, we get 1 over 2t plus c. And then sub in 0 into the equation, we get negative 1 over 2, 1 over 4i plus 1 over 4k plus c. And then we have here the r0, 1 over 4i plus 2j plus 3 over 4k equals to 1 over 4i plus 1 over 4k. We can get the c is equal to 1 over 2i plus 1 over 2j plus 1 over 2k. When we combine the C equation here and also VT here, we can get negative cos 2k over 4 plus 1 over 2, because here the same, it is I. We can combine it and get plus 2t power of 2 plus 1 over 2 j, here j with j, and then lastly t power of 2t over 4 minus 1 over 2t plus 1 over 2k.
In conclusion, to summarize, there is 18 questions that were solved throughout the entire duration. Methods such as sketching, differentiation rules, vector rules, rate of change rules, R equal to D over T, were used to solve specific questions. With active cooperation and teamwork, we have managed to finish this project on time.